Welcome, everybody. Thanks for joining our workshop, Taming Multiple Traffic Deployments with a GitOps Strategy. We're glad you're here. It's gonna be really good. Jakub and Kingdon Barett are here, joining us to walk through how to deploy traffic using a GitOps strategy, how to bring everything into a centralized repository, and streamline your deployment and management configurations. It's going to be good. So a couple things real quick. I'm not your host. These guys are your hosts. I'm going to be in the back end. If you have questions, please feel free to send them in. You can use the chat. You can use the QA forum. Either way, we're going to get that, and we'll do our best to answer throughout the presentation. We may have to save them till the end. There's a lot to cover here. Now, this is a workshop, so there are prerequisites if you want to follow along. You should have them in your email, actually twice in your email. We'll also make sure to show you throughout the presentation the link to the GitHub repository. You'll also need 2 empty clusters, staging and prod, to act as staging and prod. They don't actually have to be that, but okay, well, that's everything I have. Guys, take it away.
Yeah, thank you, Dylan. Hello, everyone. It's so nice to be here and to have another workshop for our great community. Today, together with me is Kingdon Barett, who joined me, who will be helping me with creating that presentation. Hello, Kingdon.
Hi, thank you. It's great to be here.
Yeah, thank you for joining. Yeah, so today's topic is about deploying traffic, multiple traffic instances on 2 clusters with GitOps strategy. We will be using Flux to do that. And yeah, this is the workshop, so you can follow us while we will be presenting, while we'll be doing the workshop. But you can also repeat it offline, because the recording will be available, and the GitHub repo is already shared. Yeah, so let me start. Let's introduce ourselves. Yeah, Kingdon, would you please say a couple of words about yourself?
Yeah, hi everyone. I'm Kingdon. I'm an open source support engineer at Weaveworks. I work on Flux, which is the GitOps operator that we're going to present today. And you can find me on GitHub as Kingdon B or Yebian on Twitter.
Yeah, thank you, Kingdon. So I'm Jakub Hajek. I work for Traefik Labs. I'm product adoption specialist. And yeah, I'm a Kubernetes enthusiast. I like the whole technology around that large ecosystem. Everything what is related to the DevOps automation. It's also something what I practice a lot on my daily basis. Personally, I'm a dad, and I practice a lot of sport activities. You can find me on Twitter. Here is the link. Okay, so what are the challenges with what challenges we'll address in that workshop? So there are a couple of them. If you are a maintainer of Kubernetes, operator of Kubernetes cluster, and you have a configuration, so in most cases configuration is kept locally on your computer. And it's difficult to maintain that configuration because the configuration is not being kept in one single place. It's not versioned, it's not a Git repository. So that's one of the challenge. Even if the configuration is placed in that directory locally, it's another issue with deploying the configuration, because you can create the Kubernetes manifests, but then you can deploy it manually. And typically you are just doing a kubectl apply, so you run an imperative command that deploy Kubernetes manifest resources and create resources on your clusters. So you don't know what is the state of the cluster, you don't know what configuration has been deployed. And if you are managing that alone, yeah, it might be quite enough, but still, if you have if you have a team, the problem is significantly growing. And of course, the configuration is not immutable. Once you deploy the configuration, you can edit manually. So you can go to the server, you can edit deployment, you can edit service by adding any annotations, labels, whatever you like it. So you don't know what is exactly the state, because you haven't updated the your local files. So that's the another challenge. And again, it's not versioned, so you don't know what's the exactly version deployed on the your cluster or your cluster. So it's a quite difficult to maintain it. What else? So if you have a variety of the configuration, so if you have, for example, a couple of the environments, probably your manifest looks different for each of the environments. So you prepare Traefik for staging environment, and then you are preparing the custom configuration for production environment. You are adding some changes. You cannot create in an easy way the base configuration and just, for example, use in the automated way customized to deploy configuration on multiple environment and inherit configuration from the base configuration without having specific tools in place. Again, if you create the configuration, if you already created the configuration, it's lack of the reviewing your manifest. You cannot create PR and ask your friends, can you please have a look on it? Can you review it? Can you please add some comments? You can't do that because the configuration is not being kept in Git repository. Even if you keeping in repository, still there is a problem with validating the configuration because someone from your team can recommend some changes, but in order to check the syntax, to validate the manifest, you need to have any tools in place that will run automatically. And again, that's difficult to test the configuration before applying to the cluster. Once you deploy to the cluster, then you can test it. So those are a couple of challenges that we as a Kubernetes users, or Kubernetes operators face every day. So that's we need to somehow solve it. So how Flux, yeah.
To take it back and just kick it up altitude a little bit to like 30,000 feet was really one challenge we want to solve. We want there to be a single source of truth for configuration changes so that they can be transparent, validated, and not happen on somebody's laptop. So it's transparent and easy to apply changes with low risk.
Exactly. So how Flux can help with solving those challenges?
So these are the GitOps principles. This is a recent publication that you can find out more about on opengitops.dev. And these are the central ideas that make GitOps a coherent, unified concept. There's different GitOps operators. Flux is not the only one. We're going to show up today Flux, though. And most of these ideas you can probably understand just by reading the names. But the one that I want to focus on first is this declarative concept. And because we're using Kubernetes, all of our resources are always declarative. So this is a feature of Kubernetes that GitOps and Flux take full advantage of to make your configuration deployment experience good. Okay. The rest of these, the version and immutable, those are properties of Git, pulled automatically by agents that run inside of the cluster and continuously reconciled. These are what make the changes easy. The declarative part is what makes it transparent. So what does Flux itself actually do? Flux exposes an interface to this tool called Customize that's used for building and applying YAML to your cluster. And not only Customize, but also Helm. What we have here on the screen is an example of a customization. So we're going to see a lot more of these as we go through the workshop. Customize and Helm can be used together in Flux. We'll see that as well in some degree. Let's go to the next slide. So there are lots of features of Flux that we are not going to cover today. Webhook receivers may be near the top of the list. We will cover repository structure in some detail. Setting up monitoring is another feature of Flux that is super important. All of these features are really super important. And if you're using Flux in production, you should read all of the docs and turn on all of the features. Each of them fits a use case that we've had real people in production express, and especially secret handling. You can't really deploy clusters in production without a solution for secret handling. We go to the next slide. So there are lots of, these look like the same links. I think we lost, there are a lot more links. Anyway, if we go to the next page, this is the root URL that you should visit to find out about Flux. And in fact, just go to the fluxcd.io site. we have some great copy there too as well. But let's go ahead.
Yeah, so thank you, Kingdon, for explaining the principles and explaining what is the Flux. This is a great tool. Personally, I use it on my daily basis and like it very much. And today we try to deploy Traefik using a Flux, using a GitOps approach. So just to give you some recap, what is the Traefik? So Traefik is it's an ingress controller. So because we are in the Kubernetes world, Traefik acts as an ingress controller. If you use Kubernetes 1.22, considering the latest API changes, everything should work fine with Traefik 2.5 because it's already updated to meet the new changes in the latest Kubernetes version. Traefik also provides their own CRD, so it's ingress root TCP, traffic service middleware. So those objects can help you to expose services to create a configuration. Traefik is also integrated with a feature called certificate resolver. So you can create a certificate resolver and obtain certificates automatically from Let's Encrypt. We will see that in our demo. And as I mentioned, Traefik supports much more providers. Today we are just going to talk about Kubernetes because we deploy everything on Kubernetes, but Traefik supports Docker Swarm. It works perfectly with a console, with Nomad as an ingress controller. So definitely you should check the link. What are the other available providers? Yeah, what else about the Traefik? As I mentioned, Traefik has a concept of middlewares. So middlewares, there are small, let's say, applications that you can tweak the request. You can apply the middleware on the top, on the router, and you can tweak the request. For example, you can create you can add some headers, but you can also create some more advanced use cases. For example, circuit breaker, rate limit, and many others. Recently, we added middleware for TCP ingress route. Yeah, one of my latest workshop was related to the more advanced techniques, more advanced load balance techniques with Traefik 2.5. So you can check the link, you can check the recording. Traefik also supports the progressive deployment. Typically it's called the canary deployment, one of the most popular use cases, and it's done with Flagger. That's another tool that has been developed by Weaveworks, and hopefully we will create another session about that great tool. So how to create the canary deployment with Traefik service and Flagger. Yeah, so that's a couple of words about the Traefik. We'll see in a live demo what Traefik can do. And now let's move to the workshop overview.
So you're going to need two clusters, as we've already mentioned, if you want to follow the examples to the letter. If you only have the capacity to host one cluster, or if you're using Kind, you can still follow along. You may encounter some strange behavior, but as we go, we can address that. And if you have any questions, feel free to put them in the chat. Go ahead and get started creating clusters if you haven't already. And another prerequisite that you'll need to take care of is to get access to GitHub for Flux Bootstrap. So we're going to use this Bootstrap process that encapsulates a lot of the information and knowledge that you need to understand about Flux, and it provides it for you in a convenient package that's easy to get started with. So the first thing you need is a GitHub token, and this can be a number of different, the easiest is a personal access token. If you go into GitHub in your profile, there's developer settings and you can create a personal access token there. Or if you're using the GH CLI, we have another option. We will use the GH CLI a little bit throughout the example demo. And one of the things that it does is it puts an OAuth token in this file. So you don't necessarily need to run this script. You can just go read that file and harvest the token out of there. But this is how I actually like to do it on my own live demos when I do this. So, so if you have downloaded the GH CLI tool, you can use this workflow to log in now and save yourself the hassle of creating a personal access token. And then the next thing I think is around the lifecycle of the deploy keys. So to understand what Flux is going to do with the access token that you give it, you need to understand what a deploy key is. This is something that's scoped to the repository. Doesn't have broad access like a personal access token does to everything, just a single repository. So this is more detail than we need to know for the demo, but if you're creating a production cluster, you will want to know about the lifecycle of those deployment keys and avoid surprising revocations when you delete a personal access token, for example. So as we go through the examples, we have two ideas that we'd like to highlight, and I'll come back to these as we go. We're building this structure for testability and also for abstraction. And by abstraction, I mean extensibility. I'll use another computer sciencey word as we get to the point where it becomes relevant, but what we're trying to do is build configuration in a way where we don't have to repeat ourselves. We will assume that you are going to build a more production cluster, a more complicated production cluster than this as you develop. But these are some of the questions that you might ask as you get further through the workshop. Will we use more than one environment? We've already decided we're going to use two. Is that enough? Will we ever need more than one cluster per environment, maybe for redundancy? And it is the idea of infrastructure being consistent across all clusters, something that we agree with. That is something that we will do, we'll show in the demo how we can apply that pattern. Also, would we run multiple apps under the same cluster? In this example, we won't, but as you go on, you may see that that is a pattern that you want to apply, and that's something that Flux wants to support.
Okay,
so let's
thanks a lot. Yeah, thanks a lot, Kingdon, for that explaining the design questions, the design, how everything has been created. So let me go to the repository that has been shared with you, and we will start to going through the steps that are created. So that's the repo. There my console, and I already export the variables for GitHub token, GitHub user, and GitHub repository. However, there is nothing created in my local directory, just only the exported context for one of the cluster T1 that is acting as a staging environment, and T2 that is acting as a production environment. So let's move forward. So first step is just to creating the Git repository. So in that case, we'll use the gh repo command to create the repository. So the repository will be automatically created and cloned in my local directory. So here is the repo. It should be also created on my GitHub account. Yeah, let me briefly refresh in the second window. I don't have to do anything here. It's just an empty repository. So let me move forward. In order to practice that, follow that example, we need to create specific directory structure. So the first step is to create following directory structure for apps, where we'll keep the base. So the base, that will be base configuration that we'll be deploying on the production and staging, but with some changes in production and staging, because for staging, for example, we need more replica or a little different configuration. Infrastructure, this is something that should be common for those two clusters that we are going to create. So the CRDs, because Traefik relies on the CRDs, so it should be deployed on the production as well as on the staging environment. And the clusters, those directories are required for Flux. So let me just create the empty directories. So as you can see, we have a similar structure here. And the first step is to create the basic base configuration for Traefik. So Traefik requires to have a cluster role with a specific privileges. It requires to have a service account and cluster role binding. So let me copy that code snippet. It will create a file in the apps-based Traefik airbag.yaml. So let me copy that and just paste here. Yeah, so the file has been created, airbag.yaml. Another thing that we need to have a Kubernetes deployment. So it's common object for Kubernetes. If you deploy anything, it's most cases is a deployment. So Traefik will be deployed as a deployment, So that's the standard Kubernetes manifest for deploying Traefik. We use a couple of the arguments in the static configuration. So we, first of all, we create we'll deploy Traefik 2.5.4. We create 3 entry points. 2 of them will be acting as HTTP and HTTPS. We'll expose API. Provider will enable Kubernetes CRD provider and allow to use cross namespace. Used to objects from the different namespaces. Some readiness and liveness props, resource limits, ports, and that's all. Let me create that file. Again, it will be created in the base configuration. So as you can see, everything what I'm doing right now, I'm just creating the files. There is no any interaction with Kubernetes yet. Just creating the configuration locally. So once the deployment is created, we need to create a service because Traefik, that's the topology of the networking in Kubernetes. We need to have any service to expose another application. So let me create the load balancer type service. That's created. And now we need to use customize object, customize resource. And that resource will be adding those 3 files that we have just creating as the resources. So airbag, Traefik, SVC. And it will be created in apps-based Traefik customization.yaml. Yeah, so we have those 4 files created in apps-based Traefik. And now let's create that's the base configuration. And now we will be creating configuration specifically for production and staging environment, but we will be inherited from that base configuration. So let me first create the dedicated namespace.
Ding, ding, ding. You said the magic word. That was the one I was saving for later. Inheritance. That's what we're building here.
Exactly. So we will just use a base configuration and just create a patch, and we'll update only those arguments, those things that are required for production. So yeah, in production, in Traefik, let's create the namespace, just a standard Kubernetes object that's created. And now, as you can see, we'll be creating patch, Traefik patch.yaml, and we will be patching the deployment, the base deployment that I created earlier. So what are the changes here? We will just, as you can see, we will just add here some arguments for certificate resolver. So nothing special, but we will ask production environment to obtain certificates from the production Let's Encrypt server. And now we need to create the customization to add those resources that we have created. So we created 3 resources, actually 2 resources, but one of them will be base resource. So as you can see, we use a namespace and we inherit from the base configuration we created. And here we are using the patch strategic merge feature from Customize, and it will patch the existing configuration in that directory. So let me copy that. Yeah, the same stuff we will do for the similar we will do for a staging environment. So we'll deploy the separate dedicated namespace. We create this dedicated namespace in staging Traefik namespace.yaml. We will create the configuration for deployment, but we will add the new staging server because that's a staging environment, and let's say we would like to obtain certificates from the staging environment because we are testing our configuration. So that's the difference between those 2 patches. And again, similar object, but it will be running in the staging environment, and all those resources will be deploying in the namespace Traefik staging. Again, we just created files, no interactions with Kubernetes yet, just the empty files in the repository, right? So as you can see, there is nothing added here yet. Okay, and now let's focus more about on the Traefik and the Flux, because now, as I mentioned, Traefik requires to have a CRD deployed. So that's the dependency. We cannot start Traefik deployment without having CRDs in our clusters. So we need to use the directory infrastructure that is common for production and staging environment. So we will create the object, a resource from Flux that is called Git repository, and that object will be pointing to Traefik's Helm chart repository, and it will use that tag, and it will exclude everything except CRDs. So if you go to that URL, you will see that in that location there are just a YAML file with all CRDs. And now we use a customization object, and I will pause here for a while because we will just refer to each of the CRD that are required to have a Traefik deployed, and that object refers to the Git repository. That's the source reference, and it creates the it refers to the source reference in the Git repository named Traefik CRD. So that's exactly that object, and it will create all those CRDs. Let me copy that snippet.
I'm going to highlight real quickly, this is a V1 Beta 1 Flux customization, and Flux will transparently upgrade it for you. This is probably a lot more information than you need to have right now, but as we go along, you may find that health checks are a feature that are interesting for you. In this case, we're using it to make sure that those resources are actually present in the remote CRD Git repository.
Yeah, thank you, Kingdon, for that comment. And yeah, because we created that file, we need to create again customization resource in the infrastructure CRD. So let me copy that file. It adds the only one resource, but as you can see, there are two objects: Git repository and customization. Okay, and now we just need to have another customization to process everything what is, to ask Flux to apply everything what is inside that CRDs directory. Okay, let me check what we have here. Yeah, so base, production, staging, and CRDs for Traefik Traefik resources. That's fine. And now we need to create the base configuration for Flux, initial configuration for Flux. So in clusters production, we'll create the file apps.yaml, and we will create the customization, and we'll ask Flux to deploy all resources that are stored in the apps production in a production cluster. But as you can see, there is a depends on, so it will depend on the infrastructure directory. So before starting applying everything what is here, what is stored here, the first it will be deployed infrastructure. And as you can see, we have two nice parameter attributes here, prune. So Flux will create resources, but it also can delete resources. So if we remove any of those files, Flux will also delete those resources. And there is a smart attribute called wait. And I think, Kingdon, you can say a couple of words about it.
Yeah, so we pointed out the health checks earlier in the V1 Beta 1 Flux API. So Flux development moves quickly. V1 Beta 2 was released in Flux 0.18, which was a few months ago already, maybe 2 months. What this feature wait does is it explicitly applies health checks to every resource in the customization if it supports case status. So what a health check does, to be explicit, if the resource supports case status, it will not only check to make sure that that resource is valid, but also that it is healthy before the customization is reflected as healthy. So in previous versions, you could enable or disable validation. That's no longer a possibility. Now it's health checks. And they can be corralled through this wait directive, so you don't have to list them all explicitly.
Yeah, thanks a lot, Kingdon. That was very helpful. So I created that file apps.yaml in production, and now we need to do similar for infrastructure, because that's another customization resource that needs to be created. As you can see, there is an interval, so Flux will be 10 minutes will be reading the repository every 10 minutes. So we created this configuration for production. Similar configuration have to be created for staging environment. But with the difference here is the path, that everything what is in app staging will be deployed in the staging environment. Again, prune set to true and wait set to true. Infrastructure. Yeah. And now we created the initial configuration. So I think now we are ready to commit our changes to Git. Again, there are no any interaction with Kubernetes yet. So let me check if the directory is the same as on my example here. Yeah, apps, clusters, customization. Yeah, I think we are good. So I will change the view. So again, this is a T1. T1 acts as a staging environment and T2 acts as a production environment. So let me now commit those changes to the Git repository. So git add dot, git status, git commit -m initial configuration. Yeah, it's committed. So git branch -m and git push to the branch main. So as you can see, I just created the first commit and I pushed the files that we have just created to my Git repository. And now I'm able to bootstrap clusters, Flux clusters. So as I mentioned, as a prerequisite, we need to have a GitHub token, GitHub user, and GitHub repo exported as an environment variable here. So this is what I already done. And now that's the first interaction with a Kubernetes. Because I have a Flux CLI installed on my computer, I will copy that snippet, and what that snippet will do, it will bootstrap Flux from the GitHub using the context that is set to T1. So that's T1. It will use the owner, so that's my GitHub account, GitHub user. It will use the repository that I created. It's again exported as a variable here. And it will use staging. It should go to the path clusters staging. And we will add some extra components for image update automation just to show you how you can add other components to the Flux. For now, we are not using that feature. Let me copy that and let's wait for a second. So as you can see, Flux is now connecting to Git repository and it's creating the manifest and it's pushing the components, creating the keys, SSH keys, using the GitHub token that is here in my exported as an environment variable. And now it started the reconciliation process. So the cluster, currently, I will show in a second, currently Flux is trying to pull the entire configuration that we have created and it's trying to deploy on the Kubernetes cluster. Let me do a git pull. Yeah. And similar, we will repeat for production. The difference is following that we will use a T2 as a context because it acts as a production and different paths of cluster production. Let me copy that and paste it here. Okay.
I wanted to mention something that's on the screen here because I forgot to highlight this earlier. When we saw our first customization, we saw these GOTK components and GOTK sync.yaml. Now this step compresses a lot of stuff into one single step, but those, yeah, thank you for highlighting that. Those are at the ground level, what is Flux? It's these two components. There's a component itself, that's all of the pods that run Flux, all of the controllers in the GitOps toolkit, and sync, which is responsible for keeping that up to date and also pulling new configuration into the cluster at the root level.
Okay, thank you a lot. So I think we are now ready to check what has been deployed by Flux, because what we have, let me just briefly summarize what we have done. We created the Git repo, we created the configuration, we commit the changes to the repository, we push the changes to the Git repo, we bootstrap Flux on 2 clusters. And now the configuration that we have just prepared should be deployed on those 2 Kubernetes clusters. So we should see Traefik deployed in the 2 separate namespaces. So let me check whether namespaces has been created. As you can see, the namespace Traefik staging has been just created. So let me go there. Yeah, let me check what has been deployed here. The Traefik is up and running just 100 seconds ago. So has been running just in yeah. Let me describe the deployment Traefik, because that's the staging, and as you can see, we use the certificate resolver staging in that case, because there's a staging environment. And yeah, service should be also created. Yeah, so let me just check the another thing on the production cluster. So I'm on the bottom, you can see the production cluster, and as you can see, the namespace has been also created, Traefik production. And here we should have a Traefik deployed. That's correct, Traefik has been deployed. kubectl describe deployment Traefik, and we don't have that line here. So in production, we are pointing to the production Let's Encrypt server. So we are good. We deployed Traefik without using any kubectl apply commands. Everything has been done from Git. So that's magic that I actually like very much. Okay, another nice comment that you should see, you should notice is Flux get all. So it will get all resources that has been created by Flux. Definitely there are much more options here. So we are just highlighting that it will get all resources. And as you can see, we have 2 Git repositories, Flux system. This is actually the repository we have created, and Git repository from Traefik CRDs. We have that revision that is locked in my customization object, and we have a revision here, and we have a customization for apps, Flux system, infrastructure, as well as for Traefik's API CRDs. So that's the great what we have already managed. So the next step, we will just deploy a sample application. Probably you are familiar with the Who Am I application, so it's quite famous, and it is always present in my all live demos. So let me create the directory structure. So in apps, in the base, we create the staging and Who Am I application directory. So let me copy that.
So far, I think we're at about 10 minutes, and we've got 2 clusters with their whole infrastructure. This is great.
This is great. Yeah, and now again, we need to create deployment, standard deployment, and in base, in Who Am I base deployment. So as you can see, that's the basic configuration, and the application will deploy some headers, will display some headers and the name foo. So let me copy that, and it will also expose the service to create the service to expose that deployment. So let me copy that snippet here. That's created, and now we will create the base ingress route. Ingress route, as I mentioned, that's a CRD for Traefik. So in that way, you can easily expose any service. So let me try to just briefly go through it. So it's ingress route. It specifies the entry points web secure, because our application will be available through HTTPS. We will create one router, and the rule will based on the matching HTTP host header. So as you can see, in that case, we use just fix.me. So we will just change that in the using customization according our environments. And it refers to the service Who Am I v1 port 80, I need to use certificate resolver feature that is called my resolver in TLS section. So let me copy that base configuration here. And again, we need to use customization to so we have a who am I base deployment ingress route customization. Okay, again, as you can see, I am just creating files. I haven't deployed anything manually. Currently my entire work with Kubernetes and with Traefik will goes to Git repository. So each change I need to create that I want to do, I need to create a file, I need to commit the file and let the Flux pull the configuration and apply it on the cluster. So now we are creating the configuration for staging environment for the application Who Am I. So we would like to have application deployed in a separate namespace because that's the good practice. So let's create the Kubernetes namespace object. And again, we are now creating a whoami.patch YAML for the base configuration. Again, we will be inherited that configuration from the base, and we'll just change the name of the header to staging because that's a staging environment. And we will now create the patch for ingress route, and the application will be available through that URL. Okay. Let me quickly do the same for, and again, I need to create a customization file to add all those resources. So namespace, base, who am I patch, and ingress route patch, because we'll use two customization, two patches for to update our configuration. And again, the same we will do for the production, but the difference is that we'll deploy in the new namespace, who am I production. So the namespace has been created. And again, we'll patch the base configuration by changing the name to production and ingress route here. Okay. So before moving forward, I need to update DNS entries because we need to create wildcard domain entry for that new service that has been created. So I will use a Cloudflare to do that. So it's SVC Traefik. Yeah, let me just run it. So it will connect to the Cloudflare because trafiklabs.tech domain is hosted in Cloudflare. So now as you can see, we created a CNAME for CNAME that is pointing to that CNAME from AWS. And the same we will do for T2. Let me check whether those comments are fine. kubectl get svc T2. Yeah, seems we are good. Let's wait a second. Yeah, it's correct. So now what we have to do, we need to commit our changes because I add some files. As you can see, there are new changes in the Git status. Yeah, we created that configuration for base, who am I production. Yeah, let me double check if you have everything correctly created. So who am I deployment ingress route customization for base. For production, yeah, we need a patch, and for stage. Yeah, seems we are good. We will see git add git commit -m add who am I application. Currently I'm pushing everything to the main branch, but of course I can create the pull request and ask my friends, my teammates to review the code. Okay, so we push the changes to Git, and now in a couple of seconds we should see that Flux was able to pull the configuration and apply it on our clusters. So I can use the reconcile just because I can use the reconcile command manually. I don't have to wait for the interval time. And now I should see the namespace. And as you can see, the namespace whoami dash staging has been created. So let me switch to the namespace to see what is inside. Staging. Okay, there are 4 replica of that deployment. Yeah, that's nice. That's nice. Let's see what's happening on the production. As you can see, whoami production has been also created. So let me switch there to see what is inside that namespace. Production kubectl get pods. And as you can see, because that server, that cluster acts as a production, we have a more replica. So we are good. So Flux was able to pull the latest changes from Git and apply it on the cluster. So we can check the ingress routes. Whoami describe. Let's check whether we have a, yeah, as you can see, it has been created correctly. Describe ingress route. Yeah, as you can see, for T1 we use whoami.t1 demo traffic labs.tech. For production we use T2. So now if I will go to the curl https whoami t1 -k, because we use a staging environment. Oops, why we don't have 404?
Just your S in HTTPS.
Thank you. Yeah, and we have a staging. We have an application running on the staging environment with a header staging. So this is exactly what we configured in our YAML files. So similar we should have in the HTTPS. Yeah, exactly, HTTPS. Whoami T2 yeah, and we have a production. So everything works as expected. So as you can see, there are no any kubectl apply, no any imperative command to apply on the cluster. Everything what we have done, we just read the state of the cluster, and we created new objects, new resources on the clusters using Git repository. And Flux was able to pull the configuration and apply it on a cluster. So that's great. I like it, that magic that just happened here. So I think that's all what we presented, what we would like to present today in regards to the technical workshop. Let me go back to the presentation because I think we have a few slides, right?
Yeah, just a couple. A little bit of wrap up.
Let me go further.
So this is the structure that we just created. And if you were following, you saw us invoke the specter of inheritance multiple times. We built an abstract interface for the computer programmers out there. You have this base directory that describes a thing that can't be instantiated by itself because it doesn't have a complete configuration. And then you have derived instances, and that's inheritance. We have an infrastructure that's in common across 2 environments, and we have an application subdirectory that is differentiated between the 2 environments. So this supports some of the really big ideas that as your configuration grows, you will need to emphasize and repeat.
Exactly.
And I think that there's one more slide. So I wanted to highlight before we close that this method in particular, deploying Flux on each cluster, is a viable strategy to scale, mainly because Flux is low on resource utilization. But depending on the scale, it may or may not make sense in your environment. If you're doing hundreds of clusters, it really might not make sense to run Flux on every one of them. Or maybe it does. It's a design decision for you to make depending on your requirements. But I wanted to highlight at least that Flux does not have to run on every cluster. There is the capability in Flux to point at a remote cluster and install resources on that. I use that to install Flux on my other clusters in a cluster API-like setting. So we have one cluster that's the management cluster, and then other clusters that are defined by the management cluster. But depending on your resource requirements and your other project requirements, your organizational structure, you can build this out however you want.
Exactly. That's the flexibility from
That's the power of Flux.
brings, yeah, that brings that tool. Okay, perfect. Thank you a lot. So that's the end of the presentation and the live demo. Thanks a lot, Kingdon. What questions do we have?
Thank you very much. Yeah, we have a little bit of time for questions, actually.
Wow.
We're not quite at the end of the hour. That's great. We did have some questions already addressed in the chat. I'm sure that we will share the recording.
Definitely.
Yeah.
We'll share the recording, and yeah, we usually create also a gist with all those questions and answers, just to make sure that everyone will get the answer. I don't know which question should I start to read first, because I just noticed the conversation in the chat here.
I've been following, and I think all of the major questions that got posed got answered. I'm wondering if there's any of them that make sense to highlight and reiterate for the recording.
We have another question here in the Q&A section that is, how does this remote cluster API fit into the Rancher managed K8's provisioning?
That's a good question. So the remote cluster API support in Flux is a field in your Flux customization, and it's kubeconfig. So you pass in secret kubeconfig, and your kubeconfig should be stored in a secret that has one data element called value with the kubeconfig file itself, base64 encoded in it. I think actually someone pointed out the other day that example is missing from the docs, but if you follow up with me on the CNCF Slack in the Flux channel, I will be happy to point you in the right direction. But I assume that Rancher works like other cluster API providers, that when you create a new cluster, it puts a secret with the kubeconfig into a namespace, and that is where the boundary between Flux and Rancher would be.
Perfect. Thank you a lot for that question and for your answer.
Here, I'll go ahead and read the questions since they're getting kind of lost in some of the feed. Is there an ETA on the Helm chart for Traefik Enterprise?
That's already released. Traefik Enterprise Helm chart has been already released. It's not yet documented because I created documentation this week, and it will be released in few days. But the Helm chart for Traefik Enterprise is already in place. It managed the components because the major components like controller and proxies, and configuration is managed through the config map and static tctl command that is for Traefik Enterprise. You can drop me a message and I will give you some more details later on regarding that Helm chart. Thank you for the question.
Okay, next one here. Can Flux point to multiple repos for one app? Say one URL for the Helm chart and another repo for the configurations?
Yes, Flux can utilize as many sources as you can throw at it. And I caveat that I haven't done extensive testing at the limits, so I don't know what the actual performance limit is or how large your cluster needs to be to handle 100,000 sources. But you can use and compose as many different sources as you want into your application. They can be Helm repositories or Git repositories, or S3 bucket source is another viable option that you can use. And those actually can have some of the same properties as a Git repository, which is why I believe that support was built. Does prune work reliably? That's an interesting question. Yes, it should work reliably. There is an inventory in each Flux customization of the resources that it is responsible for. only circumstances I can think of that it would not work reliably are if you had suspended your customization, and then nothing else will work either. So.
Yeah, so I can
One,
confirm because I also use Flux, and definitely it will remove the files, objects that you have removed from the Git repository, from the source of truth.
Yeah, prune is another feature that was drastically improved in 0.18 as well. When Flux was upgraded past server-side apply feature, there are a lot of things that became easier to code, like reliable notifications, since Flux does not have to litter each resource with a annotation for garbage collection. That was in the old design. There was an annotation that had the git commit that applied this resource. So Flux could look back and say, oh, it's not in the latest commit, so it should be deleted. And that whole system has gotten a lot less complicated now with server-side apply. So those notifications are reliable too about what's actually been created and destroyed, which is different than if you used Flux 3 or 4 months ago.
So one comment that the workshop went pretty quickly. There was a lot to cover here, and that's why. But just to make totally clear, everyone's going to get the recording here, so you can review that and even probably slow down the speed if you'd like to go through the steps. Another question. It says, might be unrelated. Is TLS cert revolver limited to just Let's Encrypt Acme ATM? Support for others like Vault PKI.
Yeah, so TLS cert resolver works with an Acme protocol. So it uses Let's Encrypt, and in Proxy, Traefik Proxy, that is an open source version, it used from what I already know with Let's Encrypt and other providers who supports Acme protocol. Vault PKI is fully supported in Traefik Enterprise, but because that's the community meeting, we are not covering the enterprise version, but I'm happy to help you. So you can reach me offline and we can discuss that topic in details.
Next question here. Concerning that remote cluster case for Flux, does that require the kube config on the managing instance, basically removing the initial benefit that Flux brought in terms of security? Also, are there plans for some agent mode initiated by the satellite cluster?
I'm not sure how to address the second question, but the first question is sort of on the nose. That's absolutely correct. The whole security model of Flux is built around this pull, and that you can keep your secrets inside of the cluster, and that the cluster itself is responsible sort of for its own destiny. And if changes come along in the master branch of the Git repository or the main branch, then they'll be applied to the cluster, but there's no other way to get them in. So this would be violating the closed loop principle, but it's not always agreed to be a requirement of GitOps. If you look at the open gitops.dev history and how the GitOps working group defined GitOps, they actually went back and forth about whether closed loop should be a principle at all. And if you see the final 1.0 version that's been released, it's not listed in there. So the jury is out on whether that's a hard requirement. Handling secrets is always going to be a challenge. I think the second question was around, I'm sorry, I didn't understand the question about agent-based.
So it said, are there plans for some agent mode initiated by the satellite cluster? There's a little bit of clarification that may be related. Thinking about an edge cluster scenario where initiating the connection doesn't work in that direction.
Oh, okay. So the cluster has a private network and it won't be accessible from the outside world. That makes sense. I'm not aware of anything that is specifically targeted to address that use case, but if you bring it up on the Flux 2 discussions, we'll certainly talk about it, and maybe we can get it in before Flux 2.0.
And it looks like the last question here, I know we're a little bit over time, but if you have a moment, how does Flux compare to Argo CD?
Oh, that's a big question. And actually the GitOps working group is currently involved in producing a good the last guide, the last answer to that question. I think I can probably locate the pull request so you can see the work that's already been done. But we like to say that they're for different use cases, and those use cases are hard to quantify. Which use cases is Flux better and which is Argo better for? This is a really hard question to answer, and I don't have a straightforward way to answer for you. But one of the advantages of Flux that I would highlight is that it has very low resource requirements. So where I think you probably wouldn't be able to install Argo on every cluster if you had hundreds of clusters, it is a viable option for Flux. Sort of dovetails with the last question about security. I think we're out of time. This has been great. The engagement, I'm pleased about the way that this talk went. Thanks everyone for coming and for your great questions. And thank you, Jakub, for putting together this great workshop.
Thanks a lot, Kingdon, for your contributing to the project, to the workshop, and I really appreciate the time we spent here together. And the community was great. Questions were great. We definitely copy all those questions and create the answers offline, and we will share the gist for Q&A session. Thank you a lot. That was a great. Thank you. Bye bye.